again. My name is Şafak Utku Sönmez. I'm a postdoctoral researcher at Université Laval. I'm quite excited to be here again because it's my third Metal Earth meeting, but it's the first time that I brought some data related to timing and the source of the mineralization events along the Destor-Porcupine fault zone. So let's get started. As you know that the southern Abitibi belt is one of the prophyllic terrains that bearing gold, and you know it consists of two different fault zones. On the north it's Destor-Porcupine, and the southern it's Ladder Lake Cadillac fault zones. And if you look at the northern part, you will see different mining camps like Timmins, Shillington, Matheson, and Parquet. And you know that they comprise different mineralization styles. One of them, the quartz carbonate veins, beautiful veins you can see here. And also some Stockberg veins hosted by the volcanic rocks as well as the intrusions. And also some quartz veins hosted by syenite or like monzonite. And the beautiful vein styles, crustiform, banded veins, and comb textures, quartz veins, and from Gibson and Parquet. So we have already heard about one of the best interpretation just before lunch, but I would like to humbly demonstrate it again in order to, remind you kindly. And you know that the volcanic rocks are the oldest part of the region, and we have porcupine volcaniclastic and sedimentary rocks around after this volcanic events. And then we have Timiskaming sedimentary deposition, which is related to the extensional event in the region. And after 2669, we have the main shortening, which is D3 here, along the Destor-Porcupine fault zone, and followed by D4 and D5. And what we know about the region is the summary of the mineralization events are the intrusion-associated stockwork veining replacements, as I showed you before. And these are related to based on the field observations, these are related to the before the D3 deformation. And we also have quartz carbonate veins, and these are related to the D3 deformation. And these are, the largest deposits in the region, right? Okay, so what is lack if you look at the data? In order to check the isotopic ages of these systems, we don't have so many data. So we have some molybdenite ages and the monazite ages, and they are perfectly overlapping with the extensional event and the D3 event. But if we would like to correlate the mineralization events, especially among the quartz carbonate veins, we can't do that because we don't have so many data. So the best case is, if we ask a question, can we do that? Maybe if we try to find the gold events which are related to monazite and xenotime, if we do the in situ uranium net dating, maybe we can constrain the mineralization events, right? And also, rhenium-osmium molybdenite aging, it's also important because if you look at the McIntyre and the Dome deposits, they are one of the biggest deposits in the Timmins. Maybe we can constrain some of the mineralization events there. Awesome. The second question is related to oxygen isotopic compositions. If you look at the Valdor region and the Timmins and Ladder Lake region, what we can see, there are two distinct, not perfectly distinct, but still it is distinct, oxygen isotopic signatures, right? So there might be related to two different deep crustal sources, or maybe there is a fluid diversion during the migration, or we don't know if the sources of the quartz veins and the quartz carbon cyanide-hosted quartz veins and the quartz carbonate veins. So we need to check it. But the problem is we don't have so many data. So therefore, what we we wanted to check the oxygen isotopic compositions of these systems along the Destor-Porcupine fault zone. Secondly, the sulfur source. It's also important to understand the rock sulfidation reactions, right? But again, the problem is lack of the data along the Destor-Porcupine fault zone. So as I told you, we aim to constrain the isotopic compositions of these quartz veins. And also the alteration minerals, because it's important to estimate the temperature. If you use the pairs, mineral pairs, you might estimate the temperature of the system. And also the bulk and in-situ sulfur isotope in order to constrain the sulfur source. Amazing. All right, so let's continue with the chapter 1, geochronology. What I have done, I went to the field last year and this year as well. So I have been to different mining areas like Timmins, Silicon, Matheson, and Duparquet. And I collected my samples from the big mines as well as the showings. Amazing. And how did we do this geochronology? Of course, there are some previous examples. Then I applied the same methods. Okay, let me try to explain. First, selection of the gold-bearing samples. So if you see the gold, and also if you know the assay results, these are the best targets to find the gold and the alteration, the xenotime and maybe monazite, which we are targeting dating, right? And to do that, we prepared our thick sections. These are polished sections, and you can see them here. Then we investigated the SEM image, we used the SEM to investigate the xenotime and monazite grains. And we also distinguished the locations of these grains because they are coming from the alteration parts as well as the quartz veins, right? So we also tried to understand the gold relation with them. Then we mapped the xenotime and the monazite locations. And there are also several samples here. You can see this is coming from stock deposit from the Shillington region. And you can see different gold events which are related to the pyrite as well as maybe second precipitation, as Maxim also demonstrated. So we try to map all of and understand all of these different events. We applied the same methodology for the Gibson crustiform and the Duparquet crustiform veins. Gibson is one of the best samples to do molybdenite aging because you can see the gold and molybdenite together. Amazing. And the Duparquet as well. And we have xenotime grains in the alteration zone, which are related to also offers pyrite grains. Then what we have done, we did EPMA to understand the chemical compositions of all of these monazites as well as xenotime. So we have to confirm that these are related to hydrothermal events, right? So we did that, and we also tried to understand the uranium concentration of these minerals because we are targeting to do uranium-lead dating. Okay. The next chapter, let's go to the lab, which is New Brunswick, and thank you for them for helping me during my, my uranium-lead dating session. And we also used the iolite for the data reduction. So we have the monazite ages, we only use the concordant ages, we omitted the discordia ages, and we did the same thing for the xenotime, and then we constrained all the ages. Okay, now I am coming to the best part of this session. All right, if you are ready, I will start. First, failed. I went to my office, opened a bottle of whiskey, and I cried. No, I didn't do that. Since we are geologists, we have to handle some of the failures, right? So these are the monazite ages. These are quite old, older than the host rock ages. So even if they are concordant because of the low uranium concentration, it didn't work. But, so what we know related to the field observations, so intrusion related rocks, stockwork veinings, these should be related to the extensional event. But if you look at the hislop, yes, it fits there, but still we have slight problem, which is uncertainty. It comes from the monazite again. All right, so what we have, we also have Duparquet and Gibson crustiform veins. What we know about them, these are related to extensional event, should be. And when we dated them, the monazite, the xenotime and the molybdenite ages, they are perfectly overlapping with the extensional event, which is predate of the D3 deformation. Amazing. So if you look at the previous ages, the molybdenite ages, and from the Dome Mine and Bufanto Garrison and McIntyre, they are also overlapping. This is great. And the last part is for sure the quartz carbonate veins, right? So these are the most important mineralization events in the region. So what we see, if you look at the distribution of the clustering, not all of, but the most of the samples, they are overlapping with the D3 deformation and D4, maybe D5, or so on, which means it is overlapping with the field observations. And these are post-dating the stockwork veining and the crustiform veining, which makes really sense when it comes to the regional geology. So let me try to compile all of my conclusions. So xenotime and monazite geochronology, it provides a valuable tool for further constrain the timing of the mineralization events, that's for sure. But, always but, since we are geologists, monazite ages require more careful screening. The reason is they might have low uranium concentrations, right? And these are also demonstrated by the other studies like Herzog et al. 2023. And monazite, it's sometimes a little bit iffy to date. And what we know also regarding the ages, intrusion-related stockwork and the crustiform style mineralizations, they are predates the main D3 shortening event, which makes sense. It fits with the field observations. And when we look at the quartz carbonate vein systems, and we call them also orogenic styles, and they formed during the D3 deformation or later. And when we look at the analytical certainties, you see that these are a little bit high, and therefore we can't systematically constrain the mineralization events. What I am trying to say, don't misunderstand me, for example, we can't say, okay, the Timmins deposit, even if they all occurred or formed during the D3 deformation, we can't say Timmins deposits, they are earlier than the Matheson deposits. At least looking at the data, we can't tell them. But what we can say, they all formed during the D3 or later. Okay, so this is my first chapter, and I'm gonna continue with the second chapter, which is stable isotopes. Unfortunately, I am not as excited as compared to the first chapter. The reason is we are still continuing our analysis, but I still brought some results. So if you look at the data distribution here, these are my samples, and there are some from the previous studies. And what we see, the results, they are mostly related to they are mostly related between, if you look at the mineral compositions, the left-hand side is the mineral composition, the right-hand side is the fluid composition. I estimated using the temperature based on 350. We still see some different patterns or signatures. There are some low low oxygen isotope compositions, and there are also some high oxygen isotopic compositions. I don't know, because we have not focused on this data yet. We have not investigated the results, because I am still waiting for some of other results here, you see. Then we will cover entire Destor-Park-1 fault zone. And also, we have some hydrogen results from the phyllosilicates like chlorite and sericite, and also and tourmaline. But what we see, the distribution, these are again the mineral results. The distribution range predominantly between -55 and -75, but always there is another pattern here which is coming from the Timmins West and Highway part. We need to understand that I am now running the oxygen, the same samples in the oxygen line. So we will compare these minerals oxygen isotopic composition of these minerals with the other ones, then we will understand what is really going on. Okay, another one is the sulfur isotope results. When we look at the sulfur isotope results, what we see, the Timmins camp here, they have generally positive sulfur isotopic signatures, whereas if you look at the Matheson, they have negative, mostly negative isotopic signatures. So maybe they might have different kind of sulfur source, but it's still early to say or talk about that because we are trying to do in situ sulfur isotope in order to better constrain this idea. So we will try to understand what's going on. So we prepared our samples. Everything is ready. We sent them to University of Alberta, and I hope they will run them within the following months. But what I have also done, so we completed the laser ablation of all of these grains in order to understand the geochemical compositions of these pyrite grains. Since I have limited time, I didn't put them here, but we will also investigate that. We will merge everything. Then we will present the results soon, I hope. Okay, so let me wrap up everything. So geochronology part of my research, it's done. So we finished the uranium osmium molybdenite results and uranium-lead in situ xenotime and monoxides, and we finished the EPMA measurements, so we are ready to prepare or draft a manuscript for this. When it comes to the isotopic part of my research, is still ongoing. We finished the oxygen isotope from the quartz. We finished the hydrogen isotopes from the phyllosilicates and tourmaline. And we are still running some of the samples from the phyllosilicates and tourmaline. Hope we will get the results maybe in April or May, because we are planning to send them to the lab mid of March. And when it comes to the sulfur isotopes, bulk delta 34S, it's done. And in situ sulfur, it's still ongoing. So we are waiting for that maybe by late April. Then we will finish the research along the Destor-Polkfine zone, and hopefully we will publish some good results related to this study. And also I would like to acknowledge all of these companies. I felt I was at home, and they helped me a lot. And we also visited the Rome and University of Toronto. So we also have some samples from Robert Morris coming from the Dome mine. So I compiled everything. So thank you very much for everyone. So these are some of the fancy photos from my figure. Don't worry, I obeyed all of the rules of Canada Fieldworks. If it is danger, I wouldn't go there. So I obeyed the speed limit, so everything was fine. I really enjoyed my field session. And I would like to also thank to Evan, who assisted me this summer for my field work, and he helped me a lot during my field study. And thank you very much for your attention. If you have questions, feel free.